So thank you, everyone, for attending this product webinar. Today, we're going to talk about inverter line monitor with surge and our soft starts and ICM, industry's most trusted brand. So let's go ahead and roll through this thing. The inverter line monitor with surge protection is really designed for any inverter equipment where there's not an onboard contactor. That's how we cut power with our other line monitors is we open the coil circuit of the contactor. So the ICM493 includes an onboard transformer and contactor, so we can monitor the incoming line voltage and then break power to the system if there are any anomalies. In addition to that, we have built-in surge protection. The screen that you see right here, I just scraped from our video loops, which you can go out to the ICM resources tab, go to the media library, and you can look at different videos that are available. These are loop videos that are intended for distributors, and it's just kind of a glamour shot of the product. And bullet points will slide in. It's really well done, and some of them are only 30 seconds long, maybe a minute. And we have a whole bunch of different products, all our most popular stuff on these video loops, and those are directly downloadable from the website. And so this is what they look like. We also have today we're going to talk about the ICM870 series. These are our soft starts and available in 9, 16, and 32 amps. So let's go ahead and we'll dive a little deeper into these. And if you have any questions as we're going, please don't hesitate. We'll try to answer all your questions as we move along. But why do you need a line voltage monitor? There are many conditions that cause anomalies that can damage expensive equipment. So incoming line voltage from the power supply can vary above or below the requirements for a variety of different reasons. Operating electrical equipment outside of stated parameters can damage compressors, especially circuit boards, number of different things that can be damaged by power anomalies. And then there are certain situations that are fairly common, put excess pressure on the power grid. Peak time. We see a lot of anomalies happen during peak time, especially on really hot days. Demand's really high in the afternoon, and that can put some additional pressure on the power grid. Extreme weather conditions, and that's probably where most of the power anomalies come from. And then nowadays, there's a push to electrify everything, which is putting even more pressure on the power grid, and that's also causing some additional issues. So just a real quick overview here of how power is transmitted. So power generation stations produce power, hydroelectric, we got wind, we got solar, we have a bunch of different methods of producing power these days. And then the power plant then steps up the voltage so it can travel long distances across the countryside. You see the big metal poles, towering metal poles transferring that electricity. It really has to be ramped up so it can travel those long distances. Then it comes into a substation where it breaks it down, back down, suitable for powering things like industry. A lot of industrial power is 600. That's the first thing downstream from the power generation, from the transmission substation. And then it'll be broken down again in another substation, providing 460 volt to most of the things that we deal with on a commercial level are going to be in that 460 volt range. And they have different ways of utilizing that 460 where they can break legs off and then have, 230 volt power and 115 volt power off single sources. But then they break it down again for our neighborhood. So 230 volt comes into our neighborhood, comes into the panel in your house. They call it a split phase panel because you have 230 volts coming in, L1 and L2, each one going to its own bus bar, 115 volts, 115 volts. So most of the things in your home are powered off 115, But then the things that run on 230, like your air conditioner, dryer, maybe an oven, things like that, they'll use dual breaker, 2-pole breaker that'll touch both bus bars, and that's how you get your 230 volts. But there's so many things that can happen downstream. Car hitting a power pole, weather conditions, like we say, maybe a tree limb falls and takes out a transformer, various things. But things can happen all the way upstream too that can then transfer problems downstream. So a lot of different um, conditions that can happen that can cause those power anomalies, lightning, various things like that. But just the electrostatic energy in the atmosphere during storms and things can cause these impulsive transients. So this surge or spike is a very rapid event. It's a huge spike that happens in a very short duration of time, and that can really cause you some problems. And that this is why you need surge protection. So line monitors look at sine waves over a longer period of time. Impulsive surge, it's so fast that a line monitor is not even going to pick that up. It's a totally different type of event. And that's why you need both surge and line monitor. So a line monitor is not a surge protector. Uh, a surge protector is not a line monitor. Line monitors look at this voltage over time. They're looking at those sine waves, and you can adjust our line monitors to interrogate for a longer period of time if you want to. So really, it wants to see several cycles, because it may be high on one cycle or it may be low on one cycle, but it may correct itself next time through. So we want to make sure that there's a problem, an actual problem with incoming power, before we take equipment offline. So a line monitor is doing exactly that. It's monitoring that line voltage, watching it, and watching for the anomalies, and then will drop, will cut power to the system when it determines that there is actually a problem with incoming line voltage. Um, it protects on both over and undercurrent situations. A surge protector only protects against that surge. It does nothing for under current, and it's only looking for that surge, which it converts excess energy into heat, which then gets drawn internally to the TMOV, which is the device inside. I'll talk about that here in a sec, and is trying to dissipate that heat off. So very, very rapid event. To kind of give you an idea of how those TMOVs work, this is a larger scale. We've all seen transformers on a power pole, and we've seen these devices hanging on the side. What this is over here on the left with the fins on it is a surge device, and it's got MOVs in there, metal oxide varistor, and it's a semiconductor that's sensitive to voltage. So at normal voltage, um, there's basically zero resistance at normal voltage. Higher currents will then draw that heat internal to the MOV, which is filled with zinc metal oxide. And zinc metal oxide has real good heat dissipation properties. And we'll take a look at that here in a second, the ones that we use for our devices. But, it's funny that homeowners already use surge protection devices, and the power strips and the various things that you use to protect your TV, um, you know, other expensive equipment, computers, music equipment, you name it. Where do you put a surge protector in your house to protect the expensive equipment? The reason you do that is because you don't want to burn the equipment up and have to replace it. The most expensive piece of equipment in your house is your AC system. So why wouldn't people want to protect that? And we have devices to do that for conventional AC equipment, and then this 493 that we're going to talk about for inverter equipment. But there are various types of TMOVs. There's various types of MOVs and TMOVs. Metal oxide varistors. These little uh, ball type little tab MOVs are the things that you'll see in those surge strips and other equipment. And oftentimes, if you see one of these burnt up, you can go out on the internet and look at some images. They you know can fry pretty um, what's the word I'm looking for? Um, Pretty bad. Sorry. But then there's other types of TMOVs, thermally protected metal oxide variable resistor. They're thermally fused and are the best for electronics manufacturing, the best component part that you can use for suppressing a surge. And this is what we use. And what's inside a TMOV? So TMOVs are filled with zinc metal oxide grains, which have good heat dissipation properties. So as that overcurrent is absorbed inside the TMOV, this thing heats up in here and it's trying to dissipate that heat off. There may be enough capacity in the TMOV because surges, who knows how big a surge is. They vary in size. They can be very small. They can be very large. Um, but hopefully the TMOV will have enough capacity to dissipate that heat away, and no damage to the TMOV, keeps cranking along. Or in some cases, there may be some degradation to the TMOV. Some of the zinc metal oxide may fuse together, um, and that's what this is simulating anyway. That some of them are fused together uh, due to the heat, but there's still zinc metal oxide available that can still dissipate off heat. So they are not one and done. We get asked that question all the time. Oh, so it's a one and done. No, it'll take all the abuse that it can up to the capacity of the surge device, and so they'll continue to take hits. In addition to that, we generally have a bank of TMOVs in there, um, so they can take a lot of punishment. Inverter line monitors with surge protection, the 493. This is a single phase unit, and it's a line monitor, a line voltage monitor that's fully programmable. And then it also has a bank of built-in surge. So best of both worlds in one device, ideal for any and all inverter equipment. We've got a 40 amp version and a 60 amp version. Um, Field programmable lets you set min max parameters for your over under voltage. And it's got a 5 fault memory, which is very convenient because it's really nice to be able to see it'll tell you the exact voltage at the time of fault. And so you can really diagnose a problem um, by utilizing the 493. Digital display indicates the number of TMOVs remaining. So when you first fire this thing up, it'll say you have 5 TMOVs remaining. There's a bank of 5 in there. And the 5 TMOVs are the maximum surge protection allowed by UL. And we're best in class always on our surge devices. So it'll tell you have 5. If there is a condition that is eating up TMOVs, uh, if one goes, it'll say you have 4 TMOVs remaining. Now you have a problem. You've got some kind of an electrical anomaly that's happening, surge that is taking out TMOVs, and you can program it to lock out at any point. So if you want it to lock out completely after the first TMOV goes, so you can go look at it and inspect and see, try and figure out what's going on, or you can just let it continue to go until all the TMOVs are fried. Um, we've never seen that, so the capacity should be there to protect you on the surge side of things. And so you can set it for auto retry or manual lockout, your choice. The board inside, the front panel, so you can see this is and this picture right here doesn't show the cover. Obviously, there's a cover. It's a NEMA enclosure, NEMA 3 enclosure, and then this is the front panel that you see, the backside of the front panel where you do your programming and everything, and it folds down for easy wiring and easy access to anything you might need to get to in here. But onboard transformer, onboard contactor. These here are the TMOVs on the side. I think I've got a bigger image of that. So this is your bank of 5 TMOVs, and this is how you wire it. I mean, it couldn't be simpler. So just come off your disconnect, L1 and L2, to one side of the contactor out to the equipment. This inverter equipment doesn't have a contactor in there. So how do you cut power to the system? Onboard contactor on the 493. There's really no other way to do it. There's not a better way to do it. That's for sure. So equipment manufacturers use a contactor, very robust. It's going to, withstand the test of time. We use a contactor. There's other devices out there that use little block relays and stuff, and they're not meant to take punishment over a long time. They're a light duty switching device. We use tons of them on our furnace boards and things like that. So we're certainly very familiar with them, but that's the less robust way to go.
Hey, Keith,
Yeah,
can I just add to that? Do you mind?
yeah,
Um,
absolutely.
so one of the things about the reason why the contactor is so important is because it handles inductive loads. A lot of those block relays, they might be rated for resistive loads, like we've seen with the can't remember the name of it. There's one of those competitor models that just use those block relays, and they weren't even rated for inductive loads. They're only rated for resistive loads by UL. So the big benefit of ours is that you've got a contactor that's rated for inductive loads, so you're going to handle those type of things like motors and compressors and things like that. Whereas some of those other models might not. They might be able to switch the amperage, but they might not be rated properly for those inductive loads, and could potentially wear out faster over time.
Right, right. And that may be CoolGuard too. So
It began with a K. I can't. Cool Guard. Yeah,
CoolGuard, yeah,
yeah,
CoolGuard,
yeah, yeah.
yeah. And I'm not even sure about the Rector Seal versions and stuff. I think those are, well, I think we're the only ones with a contactor.
Correct.
So, far superior to um, to the competitor models that are using that block relay. But yeah, thank you for that. That is very important info. So now we can move on to our, unless there's any questions in regards to the 493. Awesome, awesome device. We, well, I don't know if it'd be premature for me to talk about some things that we have in the works, but we have some other things in the works along those lines that take it a little step further. And we'll be having some meetings, some webinars on that stuff. New products rolling out all the time. So the ICM870 soft starts, 9 amp, 16, and 32 amp. And these things, this has been one of the most successful launches, one of the fastest, ramped up faster than just about anything I can remember us coming out with, aside from maybe that 282 board a lot of years ago. But soft starts are really, there's a lot of buzz around these things. We're going to look at an installation video that was done by a rep of ours, and it's super impressive. I mean, that video really tells you everything you need to know. So you don't need to hear me rambling on about this stuff, but we'll go ahead and hit some points. What is a soft start? So this is a device that is designed to reduce startup current needed to start an AC unit, and it cuts startup current by 70%. video will confirm that, and other videos. I mean, we've tested these things. Talk to anybody that's installed them; they'll tell you it's amazing. And so during startup, input voltage is ramped up slowly, saving energy, wear and tear on the equipment, eliminating dimming of lights, harsh noises. Soft starts allow easier equipment startup when you're using generators, solar power. Um, in RV and marine applications, there's so many applications for it. Conveyor belts. I mean, there's so many different applications. Uh, so why do you need one? Does your HVAC system make loud noises when starting up? Mine was horrible. I have solved that problem. And do the lights dim when your AC system starts up? Maybe you're at the far end of a power grid, and you're a little bit under. This will help to uh, mitigate those issues. Are you using a generator or solar power to start your HVAC system? A 3,000-watt generator generally delivers 25 amps at 120 volts and 12.5 amps at 240. 12.5 amps at 240. Most residential AC systems are 240 and require more than 12.5 amps to start up. Much more. So demand for heat pumps and solar, green energy applications, generator usage is on the rise. We're seeing a lot of that. Whole home generators, and we have generator installers, that are putting these on every new installation, and it just makes sense. It's really amazing. So 70% reduction in inrush current allows AC to operate without straining the power source, whether it's generator or other, and without the need to load shed your other devices. Um, Feature benefits: reduce inrush current by 70%. You'll hear that about 1,000 times in this presentation, but it's really impressive. Extends the life of the AC by reducing excessive torque, wear and tear, reduce loud noises, light flickering, built-in self-learning algorithm, and it optimizes a reduction of inrush current. We'll talk about that a little more. Over current protection, over under voltage monitoring, built-in start capacitor delivers necessary torque at startup, LED fault indicators for troubleshooting, ultrasonically sealed, tamper-proof enclosure, installation hardware included. And so let's see what's inside. Start relay, and I'll give a little more detail about the sequence. Smart learning algorithm, input read circuit in here, overcurrent protection. It's a Hall effect sensor monitor. Got a run relay in here that takes over after startup. Silicone controlled rectifiers. This is what performs the variable speed um, function of the device. And so the silicon controlled rectifiers are called SCR going forward here. Start capacitor, switch mode power supply allows the universal voltage, and then a start winding fuse in there.
Hey Keith, can I jump in here for a second? I just
Yep.
want to go over the new changes too. So this is an older picture. It is our first generation, so to speak, and this is great to show what's inside. But it's probably this slide should be updated in the future. But this start capacitor that's on here has been replaced with a more robust start capacitor that has a more endurance and a higher rating than is even required for our device, just for added safety. The start relay has also been replaced by solid state start circuit, so that you reduce the capability of that ever welding shut, because those relays have points in them, and over
Yeah.
time they can because of the high current and stuff that's involved, they can weld shut over time, and wear and tear. So that's been replaced with a new solid state circuitry. We've also sealed up with a special adhesive, like not an adhesive, but like a silicone based RTV type of sealant, we've sealed up some of the components that, God forbid, if ever the capacitor were to get damaged by something, wear, tear, whatever, and vent, those components would be sealed and prevent any further type of damage. So those are some of the major improvements that we've made. Plus, we've also made a software change to help with the complaint that a lot of people had, where they would get a start delay every single time. We now incorporate a progressive delay that will only come into effect if you have a fault condition or if you haven't seen 4 minutes of uninterrupted runtime. If you see 4 minutes of uninterrupted runtime and everything is good, on subsequent starts, you won't get a delay unless you have a fault or some other condition that requires a delay. So I just wanted to run over some of those quick improvements that we have made on the product.
Yeah, no, awesome. And I knew there were changes that were implemented. Should have checked with you first on this slide. It would have been very nice to get those in there. But if somebody can shoot me an updated picture of that, I'll incorporate those changes into this. But it's kind of good to know where we came from, and we engineer our own stuff, and that's what's great is if there are any issues, we get feedback from the field. We can implement those changes and change the design of the products. That's one of the advantages that you have with ICM. So how does it work? So the function is to reduce inrush current, not run load current. So at startup, start relay or start circuit brings in start cap, providing initial torque for hard start. Simultaneously, those silicon rectifiers reduce start current, and then slowly ramp up the voltage to the run winding through the smart algorithm and circuit. And the smart algorithm circuit is automatic, continuous self-learning. Can take as little as 4 trials up to 7 for full calibration. Normally, and wait till you see Matt's video. It's incredible. First time, it cuts it, but then it will optimize that. And then so the comment, I think, John, you made this comment. It's like a glorified dimmer switch for larger inductive loads. And then the smart algorithm takes a reading of the last 20 trials and makes necessary adjustments. So this thing is continuously learning forever and ever. And it's always going to use those last 20 trials. Maybe there's a condition that has developed where it needs a little more current at startup. It's going to adjust to that. Maybe it can get by with a little less. It's going to constantly learn and adjust. 870 ensures safe starting of the motor by monitoring back EMF on the run winding, and then before it transitions to the steady state run. So start relay turns off, run relay turns on, phase control drops out. During steady state, the 870 continuously monitors over current condition and over under voltage condition. So really smart device, brilliant technology. You can see by the graphs here, direct online start without the device inrush current or torque speed curve with the soft start is reduced tremendously, and same thing, current speed curve. So here's your difference: inrush current without, inrush current with the soft starter. And the video will definitely tell the story. So questions come up too: hard start versus soft start. Hard start, is a device that's designed to spike inrush current, to just dump whatever energy it has stored up at startup. It's just going to dump that on the compressor to give it a boost, to get it started. It increases inrush current to the compressor without regard to overcurrent. So, over time, you're just slamming this thing with more energy, with more current, and obviously, can shorten the life of a compressor over time. Uh, Hard start kits. So, we have this universal potential relay, and we have a universal hard start that is a little better than some of the PTCR type devices. Everybody knows, the PTCR types, and positive temperature coefficient relay. So a little disc on there, the juice dumps out of there, and then that disc heats up and drops out, and it needs to cool down before it can recycle and deliver another hit. Our 866U hard start uses this potential relay, universal potential relay, differential voltage sensing. And so it only stays engaged as long as is necessary. So it dumps the juice on the windings and differential voltage sensing. It says, okay, enough, and it drops out. So it's a smart device, but it's still a hard start, and it's just dumping that energy on the windings. Conversely, the soft start is designed to reduce starting current of the compressor by actively controlling current in both the run and start winding. So, as we talked about how the thing works internally, the smart algorithm and all those things, this is going to be more friendlier to your equipment and extend the life of the equipment as well. Soft starters, particularly well suited for the generator and solar power things, applications, as we said. And where power is limited and cable impedances over long distances can cause difficulty in starting a compressor, soft start is a perfect solution. Residential, commercial, recreational vehicles, marine, food trucks, conveyor belts, things that start and stop like that. These things can be used in a multitude of applications. Large industrial fans and motors running belts and pulleys and water pumps and whole variety of things you can benefit from using a soft start. 9 amp, 16 and 32 amp, like we say, and which model do I need? This is very important. This is very, very important. These devices need to be sized by the run load amps on the unit sticker. So compressor run load amps here is 10.9. So in this example, you can't use a 9. It's over 9. You got to go to the 16. If the run load amps is 9.1 to 16 amps, use a 16. If it's 16.1 to 32 amps, use a 32. We have some small equipment out there where a 9 amp could be utilized. A lot of apartments, there's a lot of, especially now, a lot of multifamily type dwellings that are using smaller units that could benefit from the 9 amp. Most of the stuff that we deal with, I think, with our distributors is probably in that 16 to 32 range. But there's no real rule of thumb. We tried that in the beginning, but when you try to help, like we put a little chart out and we said, okay, 1 ton, use a 9 amp, 2 ton, use a 16 or whatever. But you really, there's no rule of thumb that fits. You have to look at that rating plate and look at the RLA to determine which one to use. Some 3 tons, might still use a 16. Some may need a 32, all based on run load amps. When you get into 4 or 5, 6 ton, most of those are going to be in the 32 range. So just make sure that you inspect that equipment sticker when you're sizing your 870, and if you want to ensure long-term performance. well, can I just use a 32 for everything? I've had people ask that, and the answer is no. By oversizing the 870, and John, I'm sure you can weigh in on this too, but by oversizing the 870, you would effectively be using a much larger start capacitor than is called for, and you can't just take a capacitor off the shelf and stick it in there. You've got to get the right capacitor, and this is in that same ballpark. Oversizing also robs a user of the overcurrent protection, so you're not getting the full benefits of the device as well. It's kind of like using too large of a breaker. It'll work, but it's not going to
Yeah,
trip.
I
Yeah.
agree. Keith, I can't thank you enough for mentioning this, because this is a constant call I get. And people, especially when there's shortages on one or the other, people want to say, hey, if if I'm close, can I just go to the larger one? Well, the answer is Keith has mentioned is no. He's mentioned both of the reasons, but it's just you lose you lose the benefits of the inrush reduction a little bit, because you are using a larger cap, so you're dumping more juice onto the windings. But on the same token, you're also losing your overcurrent protection. So you're just sacrificing, too much, and it's just not. We don't recommend it.
Yeah. Yeah. And, warranty comes into question, UL certification, all those things. So just size it properly according to the RLA, and, everybody will be happy. You don't want callbacks and unhappy customers. So size it by RLA. And then what's the deal with the core sense and some of that?
Yeah. Let me talk on that for you on that, because that one's a complicated one. So thank you for bringing that up as well. The Some of these models, air conditioners, Goodman, in Nordyne, Rheem, but the one that's the most problematic for us is probably the Goodman, that have a circuit board based, what they call the comfort alert system. And what it is, it's a system monitoring system that monitors uh, pressure switches and whatnot, but it also monitors current on the run winding. And so it's meant to sort of be a monitoring alert system to monitor the functions and shut down the AC unit if it sees a problem. Well, the problem with the board mounted ones is that we can't get around it, because it controls every aspect of the system. Now, there are also, Emerson also makes uh, the Core Sense and the Comfort Alert as modules. All right. Now, the modular ones we can bypass. I've created some diagrams that you can bypass around those modular ones, because they don't affect every aspect of the air conditioning system, and you can bypass around them. But the ones that are circuit board based, the only ones that I'm aware of that really have those in them are typically the Goodman systems. The other systems like Nordyne and Rheem, they use the more modular, uh, uh, you know, um, alert systems. And those can be bypassed. So yeah, unfortunately, we don't have a workaround right now. What it interferes with is the anti-short cycle uh, device that's in our unit, the delay. The two delays, the delays from the Comfort Alert and the delay from the ICM, uh, buck each other, because the Comfort Alert shuts the system down, which creates a delay for us. Then by the time that our delay is over with, the Comfort Alert system has already tried to restart, but it doesn't see the current on the run winding, because we have the system off in a delay. So we kind of fight each other on the delays, and it just never works. So that's the only system, though, the ones that are circuit board based Comfort Alert systems, that we can't really, are not compatible with. But the other models that have the modular core sense, you can bypass around.
Okay. Yeah, and this is not going to be the norm. Most of it's going to be pretty straightforward, but always call anytime you have a question. John is there, and our other folks. We have great technical support, and they know their stuff, as you can see. So thank you, John.
You're
So
welcome.
competitive advantages. We do everything they don't. Uh, that's a quick slide, right? Um, Reduce inrush current up to 70%. Um, these other folks just don't have it, and other things too, like UL listed for residential AC units, um, over under protection, voltage protection. It comes complete with the wire loom and nice long leads, ultrasonic tamper-proof enclosure, soon to be improved to full NEMA 4X. Hopefully, we get the wire stuff straightened out. US-based factory technical support, and comes complete with hardware and everything you need. So there's a couple brands out there. We're always price competitive. That's one thing about ICM: best in class and best value. Um, far superior to a lot of the stuff that's out there. Um, Talking about this, and the reason I mention it is we are working on a solution for the wires themselves. So the unit itself is NEMA, is completely welded, closed, NEMA 4X, with the molded over harness. Problem is the wires themselves don't have an outdoor rating. So I'm not sure what's going to happen with that going forward. Maybe one of the engineers can tell us, or John. Um, but it's easy 4-wire hookup. It really is easy. Um, and we are working towards being able to mount this thing outside. But for now, you should be able to find some space in a cabinet or some way
Yeah.
to mount it
It,
within
if
the
you
unit.
need if you need to mount it outside, what we're doing right now, Keith, is we're recommending a junction box, an IP67 rated outdoor enclosure. I've been There's a specific one I've been kind of recommending because it's just such a nice one, um, made by Sapewell, and it has a nice clear plastic door, and you just mount it in there with it. You see these, you got a nice picture of the seal tight whips. Of course, you could mount it that way as well, with the seal tight whips, and we don't generally recommend it being mounted upside down, but if everything is sealed tight, then it shouldn't be an issue. Um, you, the That's all we have right now as a solution. Eventually, going forward, I would assume that on the next generation, we'll probably incorporate, to be fully weather resistant and get that NEMA rating that we need for the outdoors. But for right now, we're just, if you can't find a convenient spot in the unit or under it, like you see in these pictures, you just get an outdoor enclosure. They cost about $50, 50 to $55 on Amazon, and use a seal tight whip, and it's a nice professional job. And most of the contractors that I've talked to are pretty okay with that. They understand, and if they can find some other unique ways to, mount the device outside but seal the wires through conduit and whatnot like that, they can also do that if they prefer to.
Yeah. And so this picture does show that thing being mounted upside down, which is not recommended. You can, straight up and down is best. You can mount it on its sides, um, or on its back. But the upside down it's really mainly because of the capacitor, right? The capacitor venting or whatever.
Not really. It's more of we don't want, and it's more with the way they've got it here with those sealed tight whips. This probably okay because those are all sealed. But if they didn't have that sealed tight whip, if they just used the ICM, harness or something like that, uh, then you wouldn't want water like building up on that boot and then freezing. You know what I mean? If it froze,
Yeah.
it could split that boot, and you just don't want to take that extra chance. We like the water to drip off, if at
Yeah.
all possible, away from the product. Yep.
Yeah. Water and electronics don't mix last time I checked. Um, so Matt Valent did this video, and I want to can you hear it okay?
Hi, my name is Matt. I'm with ICM Controls.
You hear the
Today
video,
we're here
right?
at the
Sounds
Update
good.
Systems York Certified Training Lab in Syracuse, New York, and we're going to be installing the ICM870 Soft Start. Your air conditioning condenser is one of the most power demanding pieces of equipment at your house or on your property. The ICM870 has a self-learning algorithm that optimizes that peak current draw when it starts up. You may want to know why optimizing that inrush current is so desirable. Number one, it's going to prolong the life of your air conditioner by reducing the stress from startups and all the torque, all that power inrush on your compressor. Number two, this is a great option for people with a backup power source at their house, be it a backup generator or an inverter system. This is going to reduce the necessary power draw for this equipment to start up. Here are a few other features and benefits worth mentioning. It monitors system health, including under/over voltage, overcurrent, compressor startup, and self-integrity. It increases the home energy efficiency, reduces loud noises during your startup, reduces light flickering and breaker trips while using other appliances. It features a built-in start capacitor, has LED diagnostic and fault indicators. It's ultrasonic steel for a tamper-proof enclosure. It includes all the necessary installation hardware and is a UL tested and certified soft starter. A few applications for the ICM870: residential, commercial, RV, and marine air conditioners. Now there are a few models of the ICM870 that are available. There's a 9 amp and a 16 amp currently available, and then there's a 24/32 amp model that will be available summer of 2023. One of the most common questions we get is, which model do I need for my air conditioner? For this information, you're going to want to check the run load amps of your compressor, which are going to be located on your equipment sticker or in your spec guides or online for your whatever equipment you have. Today we're going to be installing this on a 2-ton system, so we're going to be using a 16 amp soft start. So let's get this installed on our air conditioner. So for today's video, we're going to actually show you what installed on our air conditioner. So for today's video, we're going to actually show you what the soft start does. So we're going to go ahead and get the initial inrush power draw for our compressor before we get this installed. Then we'll take it after just to show you how it works. So our unit is calling for cooling. We have our inrush amp meter on one of the power legs. So we're going to go ahead and turn the power on. You'll see what that inrush power is on startup. As you can see, 51.8. So that's a value we're going to want to remember for later. After we get this unit installed, you'll see how it drops that inrush power. So we're going to want to turn the power back off to install our unit. So in the ICM870 box, you're going to find a goodie bag full of 1/4-inch crimp connectors, butt connectors, grommet, zip ties, everything you'll need. Grommet, zip ties, everything you'll need for a complete install, and of course the unit. Today we're installing this on a 2-ton system, and we'll double check the power draw required. The run load amps on this is a 10.9, so we're going to use the 16 amp ICM870. So when you take it out of the bag, you're going to see it's got a nice long whip on it, about 3 feet long. It's got a wire loom. This is designed for, it's not designed for exterior use. If you need to put an exterior of your equipment, like you don't have enough room in here, You just need to put it in a NEMA 3 box. As always, disconnect your power before servicing any equipment. Step 1. You're going to take the red wire from the ICM870 and connect it to the common terminal on the run capacitor. Put our 1/4-inch connector on already. We're going to take it and put it on one of the open terminals on the run capacitor. Step 2, you're going to disconnect the compressor run wire from the T2 terminal on your contactor. Also in step 2, you're going to take the brown wire from the ICM870 and connect that to the compressor run wire, which in our case is a red wire. In this case, I like to put the female connector on, so if something ever happens with the ICM870, you just disconnect it and connect it right back onto your contactor. At this point, you're going to want to remove or disconnect any dedicated start capacitor or PTCR that's in its place. Step 3, you're going to connect the blue wire from the ICM870 to the run capacitor terminal marked HERM, hermetic, for the compressor. Step 4, you're going to take the black wire from the ICM870 and connect it to one of the terminals on the T1 or L1 side of the contactor. So now that our ICM870 is installed, we're going to put our amp meter back on. We'll check the inrush current, we'll turn the power on, make sure everything is working properly. 7.9. And if you remember, our previous reading was 52. Okay, now that we're up and running, we're going to have a green light here. It's going to go through its learning algorithms to learn the start requirements of this condenser. If there are any fault codes or any issues with the unit, you'll see there's 2 other LEDs here that will flash according to the fault code in the owner's manual. And that completes another successful installation of one of our ICM products. As always, thank you for watching.
So pretty impressive. First try, dropped the inrush current from 52 to about 8, and then we'll continue to optimize that inrush current need, and we'll continue to monitor it. So after the 20 tries, it'll continue to monitor the last 20 trials and continue to optimize the inrush current. So those videos are available if you go out to the resources tab. Installation videos on all of our products. That particular one is out there as well. Encourage your counter people at the distributors, contractors, anybody that wants to look at those. There's QR codes typically on the box. When you purchase an ICM product, scan that QR code with your phone. It'll take you right to the page for that particular product, where you can download things like these sales sheets, installation guides. Also, there's usually links for installation videos and things as well. And lots of support materials available out there on the resources tab. So this is the sell sheet. This is a comparison to some of the competitor models. This tells you how to size properly, and installation guide. And then we've got some trifolds and things too for contractors to use with homeowners. And troubleshooting, super easy. You saw the fault indicators on there. Be some flashes to let you know what the different condition is, and that label is right on the face of the product. So key benefits: cut inrush current by 70%, ramps up the input voltage slowly, saving energy wear and tear on the equipment, eliminating dimming of lights and so on. Soft starts allow easier equipment startup when using generator solar power, also in marine and RV, simple four-wire design, and superior technical support. So any questions, additional thoughts? I still have everybody out there.
Yep. I don't see
Okay.
anything coming through on the chat.
Okay. All right. As always, any questions, call us anytime. Salespeople, call our tech support department. And we're always here to help. All right. Thank you, everyone. And have a good day.
Thank you very
Thank you.
much.
Thank you.
Thank you.
Okay. See you.